Assalamualaikum everyone. Today's episode highlights a problem involving moment of force, or more commonly called torque. How is the principle of torque applied on a rigid body in static equilibrium? Join me till the end of this tutorial. Watch and learn. The question is, a uniform aluminum beam 8.00 meters long, weighing 300 point Newton, rests symmetrically on two supports, support A and support B, 4.00 meters apart. A girl weighing 500 Newton starts at point B and walks towards the left. Question letter A. How far beyond point A can the girl walk before the beam tips? Question letter B. How far from the left end of the beam should support A be placed so that the girl can walk just to the end of the beam without causing it to tip? Identifying the important data, we have the following. The length of the beam, capital L, is 8.00 meters. The distance between the two supports, denoted by small letter d, is 4.00 meters. These two supports, support A and support B, are symmetrically positioned. Alright, so that means if they are 4 meters apart, 4.00 meters apart, we say that the left end of support A, alright, is 2 meters in length, and the distance from support B to the right end of the beam is also 2 meters. Okay, we say that the two supports are symmetrically positioned. All right. Now, the body that we are analyzing in this problem is the aluminum beam. So, we need to identify the forces acting on the beam. We have the force F1, which is the upward force exerted by the support A, all right? While F2 is also the upward force exerted by support B. So both of these forces are directed upward. The weight of the girl, labeled W sub 2, which is given as 500 point Newton, meaning with 3 significant digits. Alright? The weight of the girl, which is the gravitational force of gravity, alright, is directed downward. And another force of gravity exerted on the beam is, of course, the weight of the beam itself, labeled W sub 1, which is given as 300 point Newton, also with 3 significant digits. Take note, these four forces are considered parallel coplanar forces. All right? And the summation of these vertical forces, okay, is equal to 0. So we say that the beam is in static equilibrium, right? Another way of saying that is the summation of all the forces. In this case, the summation of the vertical forces must be equal to 0. So that means the sum of the upward forces, F1 plus F2, is just equal to the sum of the downward forces, W1 plus W2. In answering question letter A, we let x of 1 be the distance beyond support A the girl can walk before the beam tips. And for question letter B, we will let x sub 2 be the distance from the left end of the beam where support A is going to be placed so that the girl can stand at the end of the beam before the beam tips. We are going to apply the principle of torque in answering both questions. So for question letter A, the torque principle is simply written this way. The clockwise torque, all right, must be equal to the counterclockwise torque about a chosen axis of rotation. So in the case of question letter A, we choose point A, or the point above the support A, as the axis of rotation. All right, and we're going to define or determine the clockwise torque that is produced, all right, uh, by the force. In this case, we are talking about uh, the force of gravity or the weight of the beam itself. Okay, the weight of the beam which passes through the midpoint of the beam. All right, its line of action is exactly at that point, which is half of 8 meters. All right, and that force, all right, will produce a clockwise torque about the chosen axis of rotation, which is point A. Now, the weight of the girl, all right, the weight of the girl, as soon as the girl has walked beyond support a distance x of 1, all right, her weight or the force of gravity exerted on the girl, all right, will be producing the counterclockwise torque about the same axis of rotation, point A. All right, so this is shown in this next step. All right, the clockwise torque produced by the weight of the beam is simply equal to the amount of the weight, which is 300 newtons in three significant figures, multiplied by its corresponding lever arm. When we say lever arm, it is the perpendicular distance between the axis of rotation. In this case, point A is the axis of rotation. All right. How far is the axis of rotation or point A from the line of action of the weight of the beam? That exactly is 1/2 of the distance d, where d is 4 meters, and so therefore half of that is equal to 2.00 meters. So the product, 300 newtons multiplied by 2.00 meters, corresponds to the clockwise torque. All right. Now, the right side of the equation represents the counterclockwise torque, and this is produced by the weight of the girl. Okay, when the girl has reached the point x of 1 beyond point A, she will be exerting a downward force equal to 500 newtons, which produces the counterclockwise torque about the axis of rotation A. All right? So her weight, 500 newtons, will be multiplied by the corresponding lever arm, x of 1, where x of 1 is our target variable. All right? So isolating x sub 1, all right, and then doing our math, we'll be able to get the value of x of 1, which is equal to 1.20 meters in three significant figures. So x of 1 is the answer to question letter A, which is the distance beyond point A the girl can walk before the beam tips. Some of you might be wondering why the upward force of support B is not included in our solution or equation for torques. All right? Well, this upward force from support B is understood to be equal to 0. Hence, its torque is also equal to 0. This is true if the beam is on the verge of tilting about the chosen axis at point A. In other words, when the girl has walked a distance x of 1 beyond support A, all right, the beam is on the verge of tilting. So, at that instant, the force exerted by support B is approaching 0. All right? That's the reason why we no longer include uh, the force exerted by support B in our equation. In answering question letter B, we let x of 2 be the distance from the left end of the beam where support A is going to be placed. And we also apply the torque principle about the axis of the rotation still at point A. 500 newtons, the girl's weight, multiplied by x of 2, which is the corresponding lever arm, represents, all right, the counterclockwise torque, while the clockwise torque is the product of the weight of the beam, 300 newtons, multiplied by the lever arm. In this case, its corresponding lever arm is 4.00 meter minus x sub 2. Alright? So, our target variable is x sub 2. Alright? And isolating x sub 2 and doing our math, we will get the value for x sub 2. Alright? After simplifying, we will get the value 1.50 meters. So this means that support A, okay, should be placed 1.50 meters from the left end of the beam so that the girl can walk just to the end of the beam without causing it to tip. So that's our answer to question letter B. And that concludes our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.